Concentration of solution. When you dissolve a solid, it might look like it disappears, but mass tells you it's still there. When you have solute mixed with solvent, it becomes a solution. Solution is a homogeneous mixture of two or more substances. Homogeneous means in a solution you cannot differentiate which one is solvent, which one is solute. That's homogeneous. Solvent is a substance present in the larger amount, while solute is a substance present in the smaller amount. Concentration can be expressed into 5 different terms: molarity, molality, mole fraction, percentage by mass, percentage by volume. Molarity is the number of moles of solute in 1 liter of solution, while molality is the number of moles of solute dissolved in 1 kilogram of solvent. The difference between these two: for molarity, it's in 1 liter of solution. Make sure that when you define or state the definition of molarity, you have to specify it's in 1 liter of solution. Meanwhile, for molality, it's in 1 kilogram of solvent. Note that for molarity, it's solution, for molality, it's solvent, and molarity, it's volume, molality, it's the mass. Mole fraction is the ratio of the number of moles of one component to the total number of moles present in the solution. Total number of moles present in solution is the number of moles of solute plus the number of moles of solvent. Percentage by mass: ratio of the mass of a solute to the mass of the solution multiplied by 100%. Note that mass of solution equal to mass of solute plus mass of solvent. Same goes to percentage by volume, but it's the ratio of the volume of a solute to the volume of the solution multiplied by 100%. Molarity: number of moles of solute in 1 liter of solution. This is the formula for molarity: number of moles of solute over volume of solution. The volume of solution must be in liter. The unit for molarity is capital M, or mole per liter, or mole per decimeter cube. For example, a student prepared a solution of sodium chloride by dissolving 1.461 gram of sodium chloride in a 250 ml volumetric flask. What is the molarity of this solution?
First, we have to identify the number of mole of sodium chloride, because the formula of molarity is number of mole of solute divided by volume of solution. So in order to get the number of mole of solute, our sodium chloride is the solute. Given the mass of sodium chloride, find the number of mole. To find the number of mole of sodium chloride, the mass of sodium chloride divided by molar mass of sodium chloride, and you get the number of mole of 0.025 mole. Substitute this value into the formula of molarity: number of mole of sodium chloride over volume of solution. The volume of solution is given 250 ml, but don't forget that the volume of solution in the molarity formula must be in liter, so you have to convert 250 ml to the liter. So 0.025 mole divided by 0.25 liter, and the answer for this question is 0.1 molar sodium chloride solution. Molality: molality is the number of mole of solute dissolved in 1 kilogram of solvent. The formula of molality is number of moles of solute divided by mass of solvent, and the mass of solvent must be in kilogram. The unit is small letter m or molal or mole per kilogram. Example, a solution containing 8.89 gram glycerol in 75 gram of ethanol. What is the molality of the solution? We have to identify which one is the solute, which one is the solvent, because the formula of molality equal number of mole of solute over mass of solvent. Which one is the mass of solvent depends on the amount of the given substance. So this is 8.89, is 175 gram. The substance which has larger amount is the solvent. The substance which has smaller amount is the solute. So this is the solvent. So you have to substitute 75 gram into the formula of molality. Molality equal number of mole of solute over mass of solvent. So our solvent is ethanol because ethanol is present in larger amount compared to glycerol. For you to substitute the number of mole, you have to find the number of mole using given mass. So mole of glycerol, because our glycerol is solute, mass of glycerol over molar mass of glycerol, and you get 0.0966 mole. This is the number of mole of solute. So you can substitute into the molality formula number of mole of solute 0.0966 over mass of solvent. Our solvent is ethanol, but mass of solvent must be in kilogram. So you convert 75 gram into kilogram, you'll get 0.075 kilogram. The answer is 1.29 molal or small m. Mole fraction, the ratio of the number of moles of one component to the total number of moles present in the solution. For example, you have component A and B. The mole fraction of A equal to mole of component A over mole of component A plus mole of component B. No unit for mole fraction because it's just a mole fraction. Maximum is 100%, so the total number of mole of the component is 100%. If it's a ratio, it's 1. Mole percentage equal mole fraction times 100. Example, a sample of rubbing alcohol contains 142 gram of isopropyl alcohol and 58 gram of water. What is the mole fractions of alcohol and water? So first, we have to identify the mole fraction of alcohol, then we can identify the mole fraction of water. So you have to find the number of mole of alcohol first given the mass. So mass divided by molar mass, you can get the number of mole. This is the number of mole of isopropyl alcohol, mass divided by molar mass. You get 2.367 mole. This is the number of mole of isopropyl alcohol. Next, find the number of mole of water. Number of mole of water, mass of water over molar mass of water, you get 3.222 mole of water. Now we both have number of mole of isopropyl alcohol and number of mole of water. We want the mole fraction of alcohol first. So mole fraction of alcohol equal mole of alcohol over mole of water plus mole of alcohol. So 2.367 mole divided by the total number of mole of alcohol and water. This is the mole fraction of alcohol. And if we want the number of mole fraction of water, mole fraction of water, mole of water over total number of mole of both water and alcohol. You get 0.576. Or we know that if it's 1, the ratio of 1 mole fraction, full mole fraction is 1. So when you get 0.424 for alcohol, you just take 1 minus the number of mole of alcohol and you get the mole fraction of water. This is the alternative method. Percentage by mass. The ratio of the mass of a solute to the mass of the solution multiplied by 100%. So this is mass of solute plus mass of solvent. Note that this is mass of solution because solution is solute plus solvent. Okay, so that's why mass of solute over mass of solution, these two are the same thing. So you just use any of this, depends on the question. It is very important to identify solute, solvent and solution first before you calculate the percentage by mass. A sample of 0.892 gram of potassium chloride was dissolved in 54.6 gram of water. What is the percentage by mass of potassium chloride in this solution? We have the mass of potassium chloride, and this is water. Water is solvent, potassium chloride is solute. Water is not solution because it's not a mixture of anything. Water is pure solvent. Now we want the percentage by mass of KCl in this solution. Solution is potassium chloride plus water. Solvent is water. Solute is potassium chloride. Then you can put the formula of percentage by mass. Percentage by mass, mass of KCl. So mass of KCl is given 0.892 gram. Mass of solution is, water is solvent, not solution. So mass of solution, we know that solution is equal to solute plus solvent. So 0.892 plus 54.6 gram times by 100 because it's percentage. So you get 1.6%. This is percentage by mass of the potassium chloride. Percentage by volume. The ratio of the volume of a solute to the volume of the solution multiplied by 100%. The top part is volume of solute. The below part is a volume of solution, or volume of solvent plus volume of solute. This is volume of solution, solvent plus solute. You cannot just assume anything. So the thing that you can assume is molarity, molality, percentage by weight, percentage by volume. So we know this is the formula for molarity, molality, percentage by weight, percentage by volume. The assumption that you can make for molarity is volume of solution. Put the volume of solution as 1 liter. This is the only thing that you can assume in molarity. Don't ever assume the number of mole. You can only assume volume of solution. It's specifically for molarity only. Don't ever assume density because density is not the unit of concentration. Next, molality, mole of solute over mass of solvent. Okay. The thing that you can assume in molality is solvent only, and the value must be 1 kilogram or 1000 gram. You can only assume the mass of solvent. Don't assume mole of solute. Next, percentage by weight. Assume the mass of solution 100 gram. Mass of solution only, and it must be 100 gram, no other value. Don't assume mass of solute, mass of solution only. Same goes with percentage by volume. You can only assume the volume of solution equal to 100 ml. A sample of commercial concentrated hydrochloric acid is 11.8 molar. HCl has a density of 1.19 gram per ml. This is the density given. The molarity of the solution is given. Now we need to calculate the percentage by mass, the molality, the mole fraction. So when you get this question, write down all the formula that is related to the question. So write down the formula of molarity. How do we know it is molarity? Look at the unit. Capital M, so it's molarity. So write the formula of molarity, write the formula of density. The question asks for percentage by mass. Write the formula for percentage by mass, the formula for molality, formula for mole fraction. Now, start with the formula of molarity. Number of mole of solute over volume of solution. And the formula for density is mass of solution over volume of solution. You've learned this during the high school. So mass of solution divided by volume of solution. Now, if you want to calculate the percentage by mass, you need mass of solute over mass of solution times 100. You need the mass of the solute. We don't have the mass of the solute in this question. Okay, you don't have the mass of the solute in this question. It's only density and molarity. So this is the kind of question that you have to do the assumption, because you only know the molarity, you don't know the number of mole, you don't know the volume of solution, and for the density, you only know the density of solution, you don't know the mass, you don't know the volume. This is where we use assumption, where you cannot solve anything given by the question. When you cannot solve anything given by the question, we must use the assumption. Assume for molarity, refer to the table. This table, the thing that we can assume is molarity, molality, percentage by weight, percentage by volume, or percentage by mass, this one. So don't ever assume density, because density is not in the table. The one that you can assume is molarity. The thing that you can assume for molarity is only volume of solution, not the number of mole, not the value of molarity itself, only the volume of solution. So now we assume volume of solution equal to 1 liter. Then substitute 1 liter here, you can get the number of mole of solute. So the number of mole of solute equal to 11.8 mole. Now, this is the number of mole of solute. If you have the number of mole of solute, you can have the mass of the solute. Mass of the solute is number of mole of solute times the molar mass. So you get the mass of the solute. 430.7 gram HCl. This is the mass of the solute. Then, mass of the solution. When we assume this is mass of solute, not mass of solution, okay, because the above part is number of mole of solute, not number of mole of solution. Okay, remember this is number of mole of solute. When you get the number of mole of solute, when you convert it to mass, the mass that you get is the mass of solute, not the mass of solution. So you cannot directly use this value to put into this formula. Okay, this is the mass of solute. We need the mass of solution. So for the density, you can use volume of solution that you get from the molarity. Because molarity, we assume volume of solution in molarity 1 liter. So now we know the volume of solution, then you can put 1 liter here. And when you have 1 liter volume of solution, you have the value of the density, you get the mass of the solution. This is the mass of the solution. 1190 gram. Mass of solution is density times the volume. Okay, volume is 1000 ml. Why 1000 ml? Why not 1 liter? Because look at the unit for density. The unit for density is gram per mil. So the mass that you get later is in gram. The volume that you must have here is in milliliter because the unit of the density. So whatever in here must follow the unit that is in density. So that's why when you get the answer is in gram. The mass is in gram because it follows the unit of the density. So this is the mass of solution. We want to calculate the percentage by mass. Now you have mass of solution, you have mass of solute, then you can solve it. Mass of solute over mass of solution times 100, you get 36.2%. Next, molality. We only solve percentage by mass. Next is the molality. Molality formula, number of mole of solute over mass of solvent. We don't have the molality value because we want to find the molality, but we have the number of mole of solute, we have the mass of solvent from the previous workings. Here we have mass of solute, we have we don't have mass of solvent, we only have mass of solution, mass of solute, but we have the number of mole of solute. This is the number of mole of solute. We have mass of solute, mass of solution, but in molality we need mass of solvent. How to get mass of solvent? We only have mass of solution, mass of solute. So mass of solvent equal to mass of solution minus mass of solution equal mass of solute plus mass of solvent. Solvent plus solute equals solution. So mass of solvent equal mass of solution minus mass of solute. Mass of solvent equals 759 gram of solvent. But mass of solvent must be in kilogram, so change it to kilogram, then substitute into the molality formula. Number of mole of solute we had previously 11.8 mole divided by 0.759 kilogram equal 15.6 molal HCl solution. Next, final one, mole fraction of HCl. Mole fraction, mole of solute over mole of solute plus mole of solvent, or mole of solute over mole of solution. Okay, mole of solute we have 11.8 mole. This is mole of solute. Now we need to find the mole of water. In order to find the mole of water, we have the mass of water from previously. So mole of water equal mass of water over molar mass of water. We have 759 gram over 18 gram per mole. For mass of water must be in gram because the molar mass is gram per mole. Don't put the mass of water in kilogram. Okay, so 759 gram over 18.0 gram per mole equal 42.2 mole water. Now we already have the number of mole of water. You can solve the equation, and the mole fraction of HCl solution is 0.219. Mole fraction of HCl 0.219. Don't ever put the unit because it's mole fraction. Mole fraction, no unit. Dilution. Dilution is a procedure for preparing less concentrated solution from a more concentrated solution. For example, this is stock solution which is concentrated. We undergo dilution process by adding more solvent into here. So the sphere bits or these like particle like stuff is the solute. Okay, it's the solute and mixed with solvent, so it's a solution. solute plus solvent solution. So dilution, you add more solvent. You don't add more solute, you add more solvent for the dilution process. And the result is dilute solution. The particle, the volume of the particle, the sphere bits, it stays the same, but the difference is the solvent here after the dilution is bigger or more than the solvent before the dilution. The number of moles of solute does not change when more solvent is added. The number of mole represent this sphere bit represent the number of mole. After dilution process, number of moles stay the same because you only add the solvent. You're not adding the solute. So number of mole of solute does not change when more solvent is added to the solution. Concentration, however, change with the added amount of solvent. The concentration change, but the number of mole doesn't change. So number of mole initial equal to number of mole final. We know that number of mole is molarity times volume, because molarity equal number of mole over volume. So number of mole equal molarity times volume. When number of mole of initial equal to the number of mole of final, so molarity initial times volume initial equal to molarity final times volume final. This is the dilution formula or dilution equation. 15 ml sample of 0.45 molar K2Cr2O4 is diluted to 100 ml. Initial volume 15 ml, final volume 100 ml. What is the concentration of the new solution? We have the molarity, we have the volume, so you can find the number of mole. Molarity initial 0.5, volume initial 15. So we know that this is the dilution quotient. So M initial, molarity initial times volume initial equal to molarity final times volume final. Just substitute. This is the molarity initial, volume initial, this is the volume final, and you get 0.0675 molar K2Cr2O4 solution.